Fifth time I'm making this video, but it's cool. It's fine. D on dx of f at x divided by g of x. We want to find how we got the quotient rule, where the quotient rule comes from. So the first thing we do is we apply first principles. We say the limit is delta x approaches 0 of, using first principles, we know that we just have to add delta x inside here and delta x inside here, and that'll be our first thing we'll write here. So we have f at x plus delta x divided by g of x plus delta x. That's what the first principles say. You just write the function where x is delta x greater than x, and then you subtract this function, the original function, because we are looking for the derivative of this entire thing. So that's f at x divided by g of x. Let's do this. Sorry. Now we need to divide all of that by delta x. Right, we are getting somewhere. I don't know if this is clear as x, but it's x. Next step. The next step is to take one denominator here. So we have a limit as delta x approaches 0 of, if we want to merge the denominators, we must multiply them. So we will have g of x times g of x plus delta x, and we'll have this multiplied by that, which will be f at x plus delta x times g of x, and we have this multiplied by that, which will be negative f at x g of x plus delta x, and we still have this delta x. I want to argue with you a simpler way. This delta x could have been written as divided by delta x on the side, so it means we could have written as divided by delta x here. If it was written as such, we could change it to be multiply and say 1 over delta x, right? Which means we can just write the delta x here, because when you multiply, the delta x would come here when you multiply 1 over delta x into this. Right, I hope you understood that. Now what we'll do is a little trick we used on the previous video, where we were explaining how we got the product rule. So we have f at x plus delta x g of x. So what we will do is we will add and subtract. But compared to the product rule, here we will add and subtract something a bit different. What we will add and subtract is we'll subtract f at x g of x and add it back, f at x g of x. Right, what does this mean? I minus something and add it back, which means this is just 0. It's the concept we keep using in maths ever since high school. When we complete the square, we add something, we subtract it again. For the high school guys, there's a video I made on adding and subtracting with making a function look like the general hyperbolic formula. And then we bring this back because it hasn't disappeared. We have f at x g of x plus delta x, all divided by what we're dividing by, which is g of x plus delta x. We're still looking for the limit as delta x approaches 0 of this entire thing. Okay, now what we are going to do is, this looks like random random procedures, yeah, random procedures where you just add and subtract, find the common denominator. But that's because it is rumored that some people were playing around with the equations, and then they came upon this wonderful discovery, which is the quotient rule. So we will also do the same thing. Now this is what we'll do. We will take out g of x. We'll take out, g of x is a common factor here between this and this, because this is minus, it's not multiply. So if you take out g of x as a common factor, you have f at x plus delta x minus f at x. And then here, we'll take out a bit of a different common factor. Well, it is f at x, but we'll take it out as a negative this time. Negative f at x. And you'll see just now why we are taking it out as a negative. We want this term, since it was negative, to be the positive one, to be the first one, g of x plus delta x. And we want g of x to be the second one, and we want it to be negative, the remainder for this one. So that's what you have so far. Oh, sorry, I forgot delta x there. Then here we have delta x, g of x plus delta x. Okay, this is going somewhere. Definitely going somewhere. Now this is when you can say you are noticing things. This is f at x plus delta x minus f at x. And we have delta x at the bottom, even though it's the denominator for these two guys. So if you were to merge these guys with a limit, this would just be the limit of f. This would just be the derivative of f. And if you were to go to this side and say there's g of x plus delta x minus g of x divided by delta x, that would be the derivative of g of x. So we are getting to our answer. Now, how do we make it such that what I just explained actually happens? First, you say limit as delta x approaches 0 of, we are going to take this denominator, we are going to distribute it across the numerators. So this numerator will have its own denominator, and this numerator will have its own denominator, but the denominators will be the same and will be this. So the first one is g of x into f at x plus delta x minus f at x. And by the way, I learned this way of finding the quotient rule from Khan Academy. I will link down their video on this as well as their channel. It's a very useful channel. They teach a lot of things for free. They offer free online classes. They're just amazing, honestly, very awesome. We have delta x, g of x plus delta x. Oh, by the way, I'm not sponsored. I'm just a kid, guys. Just a kid. F at x, g of x plus delta x minus g of x, all divided by delta x, g of x plus delta x. Okay, we are getting somewhere. Alright, now remember the limit laws. If you have the limit of a sum, it's the same as the sum of the limits. Okay, the limit of a sum is the same as the sum of the limits. So you can take the limit of this minus the limit of this as delta x approaches 0. So let's do that. We say limit as delta x approaches 0. We'll actually do it like this. You see, the limit as delta x approaches 0 of g of x Oh, sorry. You realize that the g of x's will cancel, right? Yeah, I don't think it'll be much of a problem, and there's no f at x there, but it'll come back anyways. So we have f at x minus this, so it's the limit of f at x plus delta x minus f at x divided by delta x. Okay, I want this only. I want this to be alone, right? Because it looks familiar. And you see people looking familiar, you want to make them be alone with you to communicate about life. As well as the limit delta x approaches 0. We only wrote this, and therefore we must multiply it with the limit of 1 over g of x plus delta x. The limit of 1 over g of x plus delta x. Right. If you multiply these out, they give you this, because if you multiply the limit, we can take out as a common factor and say these multiply out to give you delta x and that, and this is just the numerator. And then let's do the same thing for this side. We want the limit as delta x approaches 0 of g of x plus delta x minus g of x divided by delta x. Why do we want this to be like this? Because this still looks familiar too, and it is just the derivative of g. If this is like this, it's just the derivative of g, and this is like this, it's just the derivative of f. And what are we left with if we've taken this and this out? We've taken this, we're left with f at x, so it's limit as delta x approaches 0 of f at x as the numerator, and g of x times g of x plus delta x as the denominator. G of x times g of x plus delta x. That's your denominator. It's this one. If you can't see my handwriting, the space was limited there. This is where the fun starts. And you should get excited. Just kidding. If maths is boring for you, just pray that it is not in the future. This, as I said, is the derivative of f at x. So it's just f prime x. Right? It's just f prime x. I'm sure you can remember, this is the equation of the derivative of f at x. That's the expression. Sorry, the expression. So you have to equate it to f prime x, because you know it's equal to f prime x. Now let's look at this limit. This limit, we are saying delta x is approaching 0. And remember, the simple way to say it is, if there's nothing that will be disturbed, you can substitute delta x inside. So if you substitute delta x as 0, you just have g of x at the bottom, because you're adding nothing. So it's just 1 over g of x. I would say multiplied by 1 over g of x, but I'm just going to say divided by g of x here. It's the same thing, because g of x is your denominator. Minus this, once again, g of x plus delta x minus g of x divided by delta x. The limit of that as delta x approaches 0 is just the derivative of g, right? And this side, we have the limit as delta x approaches 0 of this. Once again, you just substitute 0 in the place of delta x, because nothing will be disturbed. But the right way to think about it is delta x is so small that it has no effect on the function, and therefore you can just ignore it. So you have g of x times g of x, because the delta x became 0. So you have the f at x as the numerator. It doesn't have anything to do with delta x, and the denominator is g of x times g of x. I'm sorry about the background music, the background sounds. I can't do anything about it. Maybe I'll figure something out. in a few upcoming days. Okay, so this is what we have. I want us to find a common denominator here, the LCD. So since we have g of x times g of x this side, the LCD is just going to be g of x squared, because g of x is in g of x squared. The way I did it is, well, the way I used to do the LCD thing, if I have something that's a factor of that, is like this. I'd say just multiply by g of x over g of x minus, here we have g prime x f at x divided by g of x all squared. This will be g of x all squared. So now you have the same denominator. You can take the same denominator, which is the LCD, and add the numerators, which is f prime x g of x minus g of x, or g prime x f at x. And that is your quotient rule. That is your quotient rule. This is it. This is it, people. This is exactly what we were looking for. When you see stuff like this, you have to be excited. Why do you have to be excited? Because mathematics is fun. Mathematics is one of the most beautiful things in the world. So this, you have derived it. I think it's useful to know how to derive these things, because when you know how to derive it, you don't forget what it is. You can't forget how to get, like, if you know how to make a shirt, how to like sew a shirt from scratch, you won't tell me you don't know where the buttons are. You don't know where the extra button is, because you made the shirt, so you know where everything is because you are the one who placed it there, right? So that's why I think it's important to know how to derive the formulae, because I will never forget the squared, because I derived it, even though it was not created by me. The method to derive it was not created by me, definitely not. But since I've also created it, since I've also used it, I can also say that I have derived it, and therefore I will not forget how to use it, how to write it. So thank you for watching once again. Subscribe, send me emails for things you want me to explain, problems you want me to do, any video recommendations, any video you would like to see. You can also say on the comments. Thank you for watching again.